Thank you for everyone joining us in this presentation around how we can simplify your Kubernetes deployments using Terraform, particularly as you're starting to think about building with OpenAI. My name's David Wright. I'm part of the field strategy team here at HashiCorp. I do love a little bit of snow and I like to follow it around the world. I am joined, thankfully, by Kelly, who is our voice of reason. Kelly, would you like to introduce yourself?
Hi, everyone. My name is 𝗬𝗲𝗀𝗀𝗻, and I'm a senior solutions engineer at HashiCorp. And a fun fact about me, I can chug a beer in 3 seconds.
Thank, thank you, Kelly. I'm not never going to buy you drinks. Right. So everyone's journey to the cloud is different. Everyone's journey and experiences in getting to an application into the cloud is going to be different. And everyone likes to think of themselves as a snowflake. However, one of the things that we have learned and know and understand in working with a lot of our customers is that as you take that unique journey to the cloud, so you're going to hit some key kind of waypoints on your way through that journey. And so what we're going to do is take a look at what those waypoints are and the important things that can help you make decisions at those waypoints to get you to your end destination as quickly and easily as possible, and to make it as easy for you to actually build and get the business value outcomes that you want. So the first part of this is obviously taking that first step towards how do I build and deliver my outcome in the cloud. And so that first step is always, we know, one of the hardest steps to take, and probably one of the biggest points in procrastination into how do we actually get this going. Fortunately, Microsoft has built a whole bunch of tools and frameworks to use and leverage to get you on that journey very quickly. So there are things like the Cloud Adoption Framework. This is also being available as code using Terraform and other infrastructure as code tools that they leverage. There are also things such as the Enterprise Scale module, which is actually in the Terraform registry, which you can actually download and use to bootstrap your environment. There are the new Azure verified modules, which allow you to actually take specific component parts, predetermined and pre-opinionated with best practices, to deploy and build those environment elements. And then as reference architectures and blueprints, there are things such as the Azure architecture and learn guides that can actually be used to pull code down and then use those as a baseline for your starting point. And so now you have that starting point, we start to think about how you can leverage that code to actually start building. So you write your code, or you transpose your code that you have found an environment that stands up from that repeatable pattern. You put it into object or version control. So this could be GitHub or Azure DevOps, for example. And so now you've established your single source of truth. This single source of truth allows you to repeatably build and stand up those environments, and for you and others to collaborate around that work. As that work is then committed, you may need to then start thinking about how and what that environment looks like, and how do you manage and control that environment using a codified approach, and also thinking about it from a standards-based practice. So things such as a SOE, so best an image that you're going to use. How do you take that base image and potentially build AI or security constraints around that image to create a golden image that is unique for that application or for a particular data source that you want to access? And so if you leverage something like 𝗬𝗲𝗃𝗃, which has the ability to create those unique images, you now have, again, a mechanism where you can create unique images, bring that into that build pipeline, and deliver it onto Azure as that platform, leveraging the cloud APIs and API in delivery and access mechanisms within that cloud infrastructure to actually start deploying your application. And so now we move from thinking about our tooling into the need to change our people and process for our orchestration. And so a lot of organizations really stumble at this point. So they have the tools, they have a mechanism, and they have the ability to now deploy infrastructure into the cloud. And so for a lot of organizations, I think that is orchestration and DevOps done. However, what we know is that really and truthfully, unless you actually start to change and establish people and process into an overarching DevOps process, create things like a platform team, then this becomes a real challenge as these individual environments start to work under their own autonomy. It's great for experimentation, not great for as you start to scale out through an organization, because each one of these groups is potentially doing the same thing. Each one of them may be using unique tools within that process, which means that that collaboration between those teams becomes really difficult. And then from a security team's perspective, how do they start to tie these things together to create a security standard or practice across this different and diverse environment? And so establishing part of your DevOps process is a key part to that move and one of those gateways in that journey or waypoint. And so once you hit this waypoint, you have to think about it in lots of different elements, not just technology, but also people, process, and overarching controls and compliance. Within this workflow, you can see how HashiCorp products, both Terraform and Vault, work with things like GitHub Actions to help build, create testing, create feedback loops into that process so that you can provision, secure, and deploy and test all within that same life cycle, and really start to automate and create a process that allows organizations to scale at speed. And an important part of this is obviously meeting that security challenge. And this is where Kelly's going to talk about this concept of shift left, which is thinking about how we integrate security into that DevOps process. So over to you, Kelly, and your Beyonce's dance moves.
Thanks, David. And as Beyonce says it best, everything that you own in a box to the left. Everything to the left. Many of us have heard of the term DevSecOps, but thinking about it in the way that David mentioned on the other slide, and in terms of your pipeline, right? The CI/CD pipeline is not just a software delivery mechanism. It also serves as a control plane that security and compliance teams can leverage to inject testing, controls, enforce policies, and build an end-to-end audit trail of changes. And it's a little bit different from a traditional security approach where we waited until analysis, design, and coding was fully completed before we handed it off to QA and security, right? But now it's really moving the security assessment into an earlier stage of your AI applications and codifying your security there. We are essentially bringing security directly into your application and automatically doing this as a part of your code building process. And so the DevOps teams work in tight, iterative, and incremental loops, and they're continually testing and reviewing changes as the code gets checked in. And why is it important? What are the outcomes of this? So this results in a reduced cost and also reduced time related to finding and fixing these problems, while also minimizing frictions, delays, and shifting left. It also puts the responsibility and the accountability for building high quality, secure software directly onto the people who are writing the code. So this will really increase your security posture while also doing these practices. And so how do we do this? Let's drill down on the next slide to talk a little bit more about how. So David had on the other slide, in the cloud world, everything is API driven. So some of the things we need to think about are, how are they secured? How are they connected? Who controls the access? And in the diagram here on the right-hand side, in that top right-hand corner, and you'll see this in the demo with David later on, how we use Vault to automate PKI infrastructure and establish certificate validation. And one of the use cases and a core use case of Vault is using Vault to secure your PKI infrastructure. And so what that means is that we are automating this process, because creating, rotating, managing certificates, it's extremely time consuming and very cumbersome. You know, there's so much manual process in terms of like generating the key, getting the CSR, submitting it to a CA, and then waiting for the verification and signing. And there's a whole people aspect of that too. One of the statistics said over 75% of organizations have experienced a certificate related outage in the past 2 years. and even Microsoft has suffered from this. So we're talking big name organizations, and it's a core use case that everyone could leverage, and as well, automating that process so that you can dynamically generate these certificates on demand. Some other ways that people use Vault to secure APIs are with basic secrets management. So you can use Vault to securely store API keys, API tokens, passwords, certificates, and you can also use dynamic secrets. So Vault can dynamically generate short-lived credentials for accessing your APIs. Instead of using long-lived API keys, Vault can generate temporary credentials on demand, to make sure that they, and you set a TTL so that they automatically expire after a certain period. The other thing you can do is encryption as a service. So you can encrypt your API keys and tokens as well, to make sure that the data is encrypted in transit and unreadable without decryption keys. And then, of course, I mentioned the end-to-end auditing part. So the access control and the audit logging is extremely essential in the security side. So we can provide comprehensive logging capabilities to make sure that you know exactly who is accessing what, and make sure that it's identity-based and that it's zero privilege, right? Zero trust. And so we want to make sure that only authorized applications and users can retrieve API keys as well. And then lastly, integration with API gateways. So a lot of organizations integrate Vault with their API gateways to dynamically fetch API keys from Vault at runtime. So this ensures that only authenticated and authorized users can access these APIs, and that they're not exposed in configuration files or environment variables. We don't want any of that. And so yeah, I mean, these are just some examples of how people are using Vault to secure their APIs, and all the way from end to end around there. And so with that, I'll hand it back over to David to talk about the next step in our journey, which is on scaling systems.
And so, thank you, Kevin. Now that we've kind of got two of the really biggest pieces of the puzzle out the way, so we've got our orchestration tooling, we've got our people and process, and we've got our security. And so the next step is thinking about how do we actually deliver at scale. And so organizations are in this fundamental battle at the moment between thinking about how they move from monolithic applications, which is where the application is all built within one construct, usually delivered by one server, to thinking about how they divide that up into separate microservices. Each one of these services is owned and run by a container or several containers that actually deliver that as then an API endpoint. And again, going back to that, thinking around what's really important is we have these API functions now that are delivering individual pieces of your application, each working with each other to deliver an overarching service. This is how organizations such as Uber and Netflix and big web frontiers or web monsters are actually building their architecture to meet this scale. Each one of them can then horizontally scale, which means that those individual containers responsible for that part of the application, if that application is becoming under pressure, can scale out and create unique copies of itself to meet that demand. But the interaction between each one of these services is based around this API endpoint. The reason that this is important from this construct is that when we think about access to large language models, most access through a large language model is by an API endpoint. We create a token that we trust, we have a conversation with that endpoint, and that endpoint then returns the tokenization response that we want based on that query. However, in that construct, we meet the same challenges that Kelly talked about in terms of how do we make sure that we got tokens rotated? How do we make sure that our certificates are rotated? How do we make sure that we're secured when leveraging these things? And so we are moving towards this API first world. We are looking to create and build more APIs as we move away, but we have to think about it in a lot more industrialized way. So moving away from the tactical way that we used to build into a repeatable, standardized cloud adoption mechanism that uses things like golden workflows, so that packer and that thinking at the very first step, leveraging extensible systems. So some of those microsystems and extendability that we talked about in that Gateway 4, and thinking about the overall lifecycle management, which is, all of the steps that we've been talking about to help deliver into creating a team. So like a platform team that can actually own the overall engineering and delivery of the services. They then have clear visibility and control and management around cost and security risks from that kind of shift left construct. And they also can mean that by working with a team of specialists, such as your AI engineers or prompt engineers, they can work with them, create a repeatable set of code through their skill. So you're leveraging that skill and not having to have lots of skills across the organization, and use that as a repeatable deliverable across different resources as they want to do the same thing. So when we think about that orchestration and those separate teams, now you have a team that has built a reusable part that anyone across the business can use to deliver a really clear, focused business outcome. And so when we think about this and going to our full cloud native, we think about leveraging all of those steps. Our landing zone is our step 1, where we take our pattern, we put that into our step 2 or gateway process. We then leverage our tooling to deliver that, and we integrate our step 3 thinking around security into that process to automate it, to then deliver that on our step 4 for our full-blown infrastructure deliver, broken up into separate services that then actually deliver our outcome. And now we're going full cloud native. If we think about this in terms of our demo and our demo scenario, we have a Microsoft Red Dog store. This is a Kubernetes-based application deployed on EKS that we are going to use as our tool. What we have done is actually integrate Vault and Cert Manager into that to automate that process. And so if we look at this, you can see that we have built our AKS cluster, sorry, not EKS, AKS cluster. And then in that, we have used a codified format to actually customize it in some way. So from our platform team perspective, we're actually thinking about how we can actually inject tags into this. So our environment is being tagged in a particular way so that we can manage cost and see who is doing it. We can also enforce tagging or a workspace or environment tagging to say that this is a demo or this is a staging or test. And so now we can actually make sure that we can actually spin up that life cycle. Next, we inject Helm. So we're using Helm within our main criteria. So we're talking to our Kubernetes, we're talking and using our Helm provider to actually inject elements into our Kubernetes environment to stand up Vault. So when we think about what Kelly was talking about and that programmatic control, we're now actually pushing that into it. And then we use that to actually stand up our environment and build our actual application. This application is using our Kubernetes manifests. So it's actually using Terraform to build the end application. And we can actually convert YAML deployments using TFKAS, which is a tool that will take the output from a deployment or a service or a config map and actually create these resources for you. If we just take a quick look at the services that are deployed, we can see that we've got our application deployed in our storefront. We have our Vault UI. So if we just take a look at what's going on with Vault, we can log into Vault here. So we log in with our highly secure
password 123.
demo 123, and we can see that we have programmatically created our PKI endpoint, and we've programmatically created our certificate. So here you can see that we have our root certificate. If we go back, you can see that we have our domain certificate. And so now using Cert Manager, so if we just take a quick look here at our secrets, you can see that within our secrets, we've actually pushed our example.tls as our root. And so within our storefront, so if we get and go and have a look, oh, actually, we need to build our endpoint. So let's just make sure we get our IP address here. Let's go and edit our host file so that we can access this. So if we now go to our end and we go in dot, was it? You can see that we are not secured. And if you look at the certificate, you can see that we've got our admin certificate here. If we drill down into those details and our version, our serial number, so you see we got 𝗦𝗽𝗀𝗀𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧𝗧 way of using a programmatic approach, we have actually driven and created a certificate that can be used on demand. And so with that, thank you very much for your time. Thank you for Kelly for coming and joining me. Thank you for talking about this. Please feel free to reach out to info@HashiCorp. Come by and see the experts on our booth. And also, if you'd like, please feel free to reach out and have a look at a blog post that covers a very similar element to this. Thank you all for your time, and hopefully this has given you something to think about and a way to attack your next problem with your Kubernetes and your Kubernetes applications. Thank you very much.
Thank you.